I'm gonna do that with you guys. I'm just kidding. Sorry, just like here. Okay, so we're trying to talk through the three types of experiments. So I got like one set up here with land and fertilizer, and I'm going to go through all three types. And then I've got another scenario with the SAT, and you're going to try to go through all three types. Okay, so for this one, what I'm trying to say in the stuff up there is you have like a 10 by 10. I'm not going to draw a 10 by 10 because you get the point with a 5 by 5, whatever. You got 100 plots of land. I know I only drew 5 by 5, but imagine it's 10 by 10. And you've got a river up here. That's my river. And we're going to go through three different types. The river doesn't matter for the first type, but it does for the second. Okay, so part A says design and diagram a completely randomized experiment that would test the new type of fertilizer. So I've really got 100 plots of land. I want to randomly assign 50 of them to get the new kind of fertilizer and 50 of them that get the old kind of fertilizer. So then at the end I could be like, well yeah, the 50 with the new kind grew a lot more than the 50 with the old kind or whatever it might be. So the first thing we have to do is randomly assign which grass gets which type. So I'm going to do a diagram, and then I'm going to write it out in words. So the diagram would be we have 100 plots of land. I'm going to split that into 50 and 50. And how am I going to do that? I'm going to do it randomly. So I write it kind of like across the arrows like that, because I went from 100 to 50 and 50. I did that randomly. And then these 50, doesn't really matter which, but let's say these 50 get the new fertilizer. These 50 get the old fertilizer. If you made data late to school, you've done something egregious. So what?
I had to go ride to school because her car broke down. But I don't live in Highland, so
Right. Well, you can't see anything, so that doesn't help. Yeah.
Actually,
Right. No, I was blaming Gearbach, not you. What? It's supposed to say old fertilizer. I don't know what it actually says. That's what I'm going for. So I've got this new fertilizer. I've got the fertilizer I've always used. I think this new kind's better, so I'm going to randomly give that to 50 plots. Just give the regular old stuff 50 plots, and then at the end, we compare growth. So you do need context there. Don't just put compare. Like, tell me what you're comparing. And then here's the thing about the diagram. It doesn't count for points. So you actually don't need to do it, but I strongly suggest you do. I think it really helps you just kind of like organize your thoughts so you can visualize what's going on. But this part doesn't get graded. What gets graded is the sentences that you write out after it. But you basically are just describing this. So probably the most important part is describing this randomization part. So let me write it out and just kind of watch, and then we'll talk about it. So it would be number each plot 1 to 100. Put the numbers in a hat. My pen. You can see it time. This is a really key phrase that the AP test needs to see. Mix them up. So that is you acknowledging that it needs to be random. If they see that, they know that you know it's supposed to be random. First 50 plots I pull out. Get the new fertilizer. rest get the old. And I've got like one sentence left. We're almost done. So number each plot 1 through 100, put the numbers in a hat and mix them up, and then you're randomly pulling. So the first 50 get the new fertilizer, the rest get the old. And it doesn't matter which order. You could say the first 50 get the old fertilizer and the next 50 get the new. Like, it doesn't matter. You're just splitting it in groups. And then we compare growth at the end. So then we could say, like, did this new fertilizer make this grass grow faster, thicker, greener, foggier? I don't know. So that's completely randomized. I didn't consider really anything. I just like, here's 100 things, 15, 50, I'll randomly decide, and we'll. I got a question for you guys. There's 3 types, right? And I want to do one of each 3, and then I want you to do one of each 3. Should we do like one at a time? Or should I do all 3 and then you do all 3? Or do you not care? You can't nod your head. It wasn't a yes no question. Right? But what'd you say? Me do all 3 of them? Okay. I thought you were just saying like yes. Okay, the black one is the kind that probably confuses people the most. So that river comes into play now. So, like, I think it makes sense that the grass, the plots closest to the river would probably go faster, right? Because there's much water. So, let's say that I randomly split the plots, and it ended up like this. And then I gave all of these ones, so like I randomly, if I just did it randomly, could it come out like that? Yeah, it's random, right? It could. And then I gave all of these ones the new fertilizer, and I gave all of these ones the old fertilizer. This is wrong. I'm trying to show you why it's wrong. I gave all the ones far away the old fertilizer. And then I find out at the end that these plots of land had grass that grew a lot faster. What's the problem? Hey. So I don't know why I grew faster, right? Was it because of the fertilizer, or was it because it was by the water? What is the water in this scenario? What's it called? What kind of variable? Lurking or confounding. Good. So this is a bad idea. Like if I was asked to do this actual experiment, I wouldn't do randomized because of this. It could come out this way. So what you have to do is 2 separate experiments. Here's my plots of land. Here's my beautiful river. I'm going to split it. Let's do like an even number. So it's, okay. I'm going to split it right here. These are the close to the river, and these are the far from the river. And then in the close, I'm going to randomly assign half of them to get the new fertilizer and half of them to get the old. So now, if the half that gets the new grows faster, like I've taken the river out of it, right? So then I'll be able to tell like what's really going on. So half of these, I don't know how to draw this, but half of these will get the new, and half of these will get the old, and then half of these will get the new, and half of these will get the old. And then, if these grow faster, I'll be able to tell, like, yeah, that was because of the new. And it might even be that, like, the new fertilizer helps when you're not near water, and it doesn't when you are near water. Like, we're just splitting it up to gain a lot more information. So let's diagram that. Write that out and see if there's questions there. So my diagram, I got 100 plots of land. And I'm going to split it into 50 that are near the river and 50 that are far away. Should I write randomly? It doesn't really matter because it's not, your diagram's not created, but should I write randomly here? Did I randomly decide which ones were near the river and which ones were away from the river? No, they just are, right? I didn't like decide that. And then I do 2 separate experiments. So now I'm going to split this into 25 and 25. And how am I going to do that? Random. I'm going to split this one into 25 and 25. I'm going to do that random. And then these 25 will get the new fertilizer, these 25 will get the old, these 25 will get the new, these 25 will get the old. And so now if all the new ones grow faster, I know it's because of the new fertilizer. It's not because of like where it was in relation to the river. At the end, you can take all the arrows and go like one central spot and put compare growth. So very often with people, you do this by gender. Say I have like 400 students, I might have 200 males, 200 females, and I do like an experiment on the females and an experiment on the males, and see if they react differently, or like upperclassmen, underclassmen, or students that drive to school, students that don't. Okay. So if I wanted to write this out, I'm going to say split the plots into 2 blocks of 50, near and far from the river. And then you don't have to write it out twice. You can just kind of say for each one. So for each, number the plots 1 to 50. Put the numbers in a hat. Mix them up. First 25 plots pulled, get the new fertilizer, get new, the rest get the old, and we compare growth at the end. So block design is running multiple experiments at the same time. And it could be more than 2. I could have done like near the river, somewhat near the river, kind of far from the river, and like really far from the river. I could split it up as much as I want. I can do freshmen, sophomores, juniors, seniors. I can do underclassmen, upperclassmen. It depends. Questions on that, on the block there? So like for the next one you're doing, I'm talking about integrated math. And I think that I'd put, so I wonder if AP students and non-AP students might react differently to integrated math. So I would block on whether a student is in AP or not. Just kind of give you hints for your next one. You do one experiment for AP students and another experiment for non-AP students. And then like run them both and compare them. Questions on block at all? Okay. And then the third kind is matched pairs. So we've got 100 plots of lands. Matched pairs means we want groups of 2. And I want these groups of 2 to be as similar as possible. So I've got the river. I've got my plots of land here. What I'm going to do is make, like these 2 are going to become a pair. And I'm going to randomly do it, but I'm going to give one of them the new fertilizer and one of them the old fertilizer. These 2, I'm trying to do like different drawings, will become a pair. these two will become a pair. So I'm just giving it like a neighbor that's next to it, and then one of them will get the new and one of them will get the old. So let's write that out. So it's going to be Gearbach canceling school. No, it's from the school.
This is an important message from Milan Area Schools. To hear the message now, press 1 or stay on the line.
Good morning, Milan School community. All of our secondary bus students are now at school. The fog this morning has gotten increasingly worse. At this late hour, a delayed start is not possible. Our drivers have been instructed to put safety before timing. If our drivers need to pause for safety, they will be pulling off the road to pause temporarily. Please know that your elementary student may be picked up late. We apologize for the inconvenience, but
It's too late. Maybe if you looked at the forecast. Like, you know.
I like how I said like it got worse. Like it wasn't my fault. It wasn't that bad.
Awful driving at 7.
Like, I almost died myself, and I almost killed other people. Let's be fair. Like, they have a bunch of kids that like walk to school. They're putting them on the street with a bunch of people who don't even drive.
I was Avery, talking about yourself.
Exactly. That's why I said
That's what like the teachers kept talking about. Like we've been driving for 30 years. It's a little bit different. You guys have been driving for like a year or two.
Yeah.
Like
We shouldn't have to drive to school.
we should not. I agree with you.
Because there's kids that walk around town going to school and I ride bikes and stuff.
What about Peter?
Yeah!
Is Peter still alive? He doesn't care if there's cars. He just goes. Yeah.
Well, she's reviving until the last second, so.
Alright, so I'm going to split the plots into groups of 2 based on location. I just put pair with a neighbor because I don't know if that was confusing or not, so I'm trying to clarify more. For the next one, just thinking ahead of the PSAT one, let's say that you had a bunch of PSAT scores. And they looked like this. You would, if you're doing matched pairs, you would do like the 2 highest go in one group, and then you randomly split. One gets the integrated math, and one gets the other one. And then the next 2, one of each, and then the next 2 get one of each. So just like for the next one you're about to do. Yeah.
So that should be like in order from like greatest to least or just however they're listed.
You want it in order from greatest to least because you want every pair to be like as similar to each other as possible. So the idea is like if you 2 have the same PSAT score and I give one of you integrated math and I give one of you not integrated math, well then at the end I might be able to be like, well yeah, integrated math helps. Like you started in the same place, you know, so I can compare them. So you want it to be as similar as possible. Oftentimes for matched pairs, the matched pair is yourself. So like what's the most similar thing to you? Is you. So for it, you can do experiments twice, or like one on each hand or something. So for example, if I want to test like a new type of mitten that I think keeps you warmer, you would put the old mitten on one hand and the new mitten on the other. And then I can, like, it's the same body, you're going to the same places, you're doing the exact same things all the time, and I can just compare it directly. It could be like, I think I've got this magic pill that makes you jump higher. So I'm going to have you jump as high as you can. And then I'll give you the pill and have you jump as high as you can. Otherwise, if I gave like Maya the pill and not Rachel and Maya jumped higher, maybe Maya just jumps higher in the first place. I don't know. So matched pairs is ideally compared to yourself. If we can't do that, then we take the most similar thing possible. Does that make sense? Okay. So split the plots into groups of 2 based on location. Flip a coin. So there still does have to be randomization in every experiment. If you remember the list of 4 things that have to be an experiment, randomization is one of them. So we didn't split the groups randomly, right? Like we very carefully put like, okay, these two together, these two together. So the randomization has to come somewhere else. So it's got to be a randomly assigned which one gets the new and which one gets the old. So flip a coin. Flip a coin is random. Flip a coin to see which plot gets new fertilizer and which plot gets old. And then we compare growth at the end. And so there's no diagram for this one because you'd be literally doing like 50 pairs. That's just absurd. No one's gonna ask you to do that. Yeah. So questions on this type? Matched pairs? Or any other three types? Alright, so you guys try the PSAT one, or the integrated math deal here. I'll write out mine, then I'll give you time to work, and we'll talk about it.
No, we can't. Oh, yeah, true.
So don't look up unless you want to read mine. And also understand, mine is not like the holy grail of answers. Like I'm not some writing expert, so they do not have to be phrased like mine. But you do have to get the same ideas across. I'll give you another minute. We'll talk about it. But if you want to read what I wrote in the meantime, go for it. Everybody okay?
Yeah, I just picked up, like I separated it, not by integrated and non-integrated, I separated it by Mr. Kraft.
So if we're doing completely randomized, we're not separating by anything. You're thinking block. Like you do a part B, I think. Completely randomized, we don't separate by anything. The teachers was in there, like to kind of teach you to see how it happened. But also, the teacher is in there so you can think about the idea of control. Control being we want to keep everything the same except for the one thing we're trying to test. So do you want to use two different teachers or do you want to use one? You want to use one. Because otherwise, if Mr. Kraft group gets way better, it could be that like he's just a way better teacher. It had nothing to do with that very much. What? Have you ever heard that, Kraft?
Put it back in my.
So completely randomized, you are not splitting it up. Well, it's not the best phrase. Because you are splitting it. You're not separating like based on some variable. next year integrated math is gone too. Yeah.
Is it based off of SAT scores every year? Like which grade is doing worse?
No, it doesn't change every like that. It was more. They kind of realized we can do integrated English like in English. So it's like a duplicate.
They're not doing integrated math next year.
But we're getting to that point with integrated math too. Yeah. So the advanced algebra teachers are going to do more SAT stuff in advanced algebra. And we're going to offer actually a regular stats class. So maybe.
Why am I here?
What?
I'm gonna use that. I tried to sign up for the
It was on the schedule last year.
split one though. Like
The split one?
the one that you had talked about that was like doing a split regular AP and reduced
Mm.
Yeah.
That was this class. It just never.
Yeah. That's the thing. I signed up for it and then they were like, oh no, you're just taking AP stats. And I was like, oh, okay.
Welcome.
Wonderful.
Yeah.
Yeah. I was.
Okay, so completely randomized. You are not looking at any of the outside variables. You are just splitting up randomly and hoping that everything just takes care of itself. So I put 100 student names in a hat, mix them up. First 50 that I pull out are going to take integrated math. The next 50 are not. You don't even have to put the part about the teacher, but you just want to make sure you're not giving them different teachers. The next 50 don't. At the end of the year, I compare SAT scores. So this is my diagram, but that bit is not actually graded. It's just like if it helps you organize it, do it. Otherwise, you don't need to worry about it. Yeah. In the end, it's fine. Yeah. When we're feeling up to it, we compare SAT scores. Any other questions on that one? All right, so part B. So given our suspicions about AP students, so I think AP students, my actual theory is the stronger the student, the more integrated math helps them. Like there's kids that are so low, they can barely even really read the questions, and like you can do as many SAT questions as you want. If you can't read, but you're not getting that. That's my personal opinion. So I would put the AP kids over here, have to integrate that. I'm gonna stop talking now. You do it. Stop looking at me, Rachel. You do it.
I did it, but now I'm second guessing myself. I don't want to erase everything that I already wrote.
Do you want me to come look at it? Oh, I know what. Let's just make that up right now. It doesn't. Let's say you've got 70 AP students, no, 70 non-AP, and 30 AP. It doesn't have to be split evenly. So what you did was you put something in your mind, and then you took each 50 and made half of the thing.
Oh, okay.
So it's like reverse.
So it should be AP over here and then students.
Yeah. So you have the right idea.
Okay. So in the second
Yeah. Yeah. So you're gonna have like your initial diagram should look like this: 70 non-AP, 30 AP, and then you should split from there.
Oh,
That is great. Unfortunately, it's 0. Right now. Look at your attitude. Because I'm not written.
Does it matter if we don't split it the way you did?
Probably what you split. Oh, because I didn't tell you what number, so you know. I wrote 70 and 30 up like after we said it, so that's good. As long as you're splitting AP in that. Yeah, it's like 15. Is that what you're asking?
Yes.
Kind of ran out of room, so I'm not like the greatest English or grammar down here, but some guys that don't read that. So yeah, keep working, check them out if you want, and then we'll talk through it. After everyone has. How many of you know that like your bright lights make fun of make works? One on the way here, like if you just got your license, you might or might not have remembered that. It's like two back, yeah. Yeah. I'm afraid if you ran out there, you would just disappear. I was like 30 miles an hour. Yeah.
I know,
Yeah.
turning.
Like I kind of know where I am driving because I see there's a certain landmarks. You know, but you can see them. So
Right,
like,
and
I'm just surrounded by fields when I drive, so it's just a lot of, I can see where everything is.
I kept waiting for. I'm going so slow. I kept waiting for Federer's giant truck to come by and like run me over. Okay. So, the idea is that I think AP matters. So I split it up by AP because I think that matters. If I thought gender mattered, like if I thought males didn't benefit from integrated math and females do or something, I would split it up based on males or females. If I thought whether you drove to school or not mattered, I would split it up on whether or not I drove to school. But whatever variable you think is like it's lurking or confounding, that's the one you're going to use. So my wording was number the 30 AP students and put the numbers in a hat, mix them up. pull out half the numbers and give them integrated math. The rest don't take integrated math. And then you can just say, like, repeat for non-AP. Like, I don't have to write all of it out again. You can say repeat that for non-AP, and then compare SATs. Questions on this one here, the block. Alright, and then the matched pairs. So, this is what I was kind of getting at before. You have a list somewhere of PSAT scores written out in order from low to high. Or high to low. Doesn't matter, I guess. And you don't have to diagram this one. You can't, because I mean you could, but it would be 50 different arrows. We don't want that. But just to make sure we understand that. Should I talk or shall I try it first? I'm stuck in the middle. Try it. Okay. Try it. Yes.
When it comes to pairing them up, what is like too far apart?
It doesn't really matter. It's the closest one. So if it was like 800, 800, 800, 800, 800, 700, like that 700 has to go with something close to it. So it would be the 800. Which is the best you can do. It might not be ideal. Like if we were pairing off by height, and let's say Trey wasn't in this class, someone would have to be my partner. And it's going to be someone who's much shorter than me, but like it's the best we can do. You're the only male in this class.
Eric and Matthew.
Right now, yeah. And Ben.
Eric, how about you?
We only have like 5.
Can I write? You know how we write like directions and all this stuff? R.I.P. for Eric.
You can, but Cornell's going to erase it next hour when he comes in. What?
Can I put up the stats column?
Wait, what? Oh, this is Eric.
And draw a little stick figure.
The stats column?
The stats column right behind you. You need to draw this.
Oh,
And then you
oh.
need a little red heart. And one for men and one for yeah, missing.
I don't care if you leave a note for Zach. Can we do the frickin' matched pairs? Good. There has to be randomization, remember. So when you have your pair, you have to randomly decide. So you have to flip a coin to see who takes integrated math and who doesn't. You can't just assign because you have biases. I have biases. We all have biases. So it could be that I think I'm randomly doing it, but I just, put all the males in integrated math. And then I don't know if integrated math helps or if males do better because of that. So you have to do it randomly when you're assigning who goes where. And if you want to, instead of flipping a coin, you could number them 1 and 2, put them in a hat, mix them up, and pull out a number. But it's a lot faster to flip a coin. Flip a coin to decide who takes integrated math, who doesn't. Compare. Remember, comparison's one of the things in the experiment. Also compare SAT scores at the end. So really matched pairs, you just have like a group there, group there, group there, group there, group there, just like forever, where one takes integrated math and one doesn't. So you have 50 of these in this scenario. So no one's going to ask you to diagram it, but just so you kind of have an idea what it would look like. Alright, so that's the 3 types: randomized, block, and matched pairs. Questions I can answer right now? Tomorrow it's just set aside for you to do con, and Monday's review, test is Tuesday. unless there's like fog scenarios involved. Yeah.